గుడ్ ఈవినింగ్ డాక్టర్.
సార్ నిన్న వచ్చినారా?
సార్ చక్రపాణి సార్, గుడ్ ఈవినింగ్ సార్. నిన్న కూడా ఉన్నాను
సార్. చక్రపాణి సార్, గుడ్ ఈవినింగ్ సార్.
ఉన్నా కాబట్టి లేట్గా వచ్చాను సార్. చక్రపాణి సార్ కూడా
ఓకే సార్. ఓకే
సార్. చక్రపాణి సార్, గుడ్ ఈవినింగ్ సార్.
సార్ గుడ్ ఈవినింగ్ సార్.
ఇందాక ఉన్నారు
సార్. అంటే ఏమన్నా మళ్ళీ ఆఫ్లైన్ వచ్చినారేమో సార్?
ఉన్నారు ఆన్లైన్ లో. శెట్టి చక్రపాణి సార్.
ఓకే ఓకే
లాస్ట్
సార్. ఏమన్నా ఇంకా విఠల్
విఠల్
విఠల్ నేను కాల్ చేస్తాను సార్. విఠల్ మన వాయిస్ వినపడినట్టుంది.
విఠల్ అన్మ్యూట్ అయింది. విఠల్ విఠల్ నేను ఆదినారాయణ సార్.
సార్ గుడ్ ఈవినింగ్ సార్. బాగున్నారా?
విఠల్ చక్రపాణి
సార్. చక్రపాణి సార్, గుడ్ ఈవినింగ్ సార్. చక్రపాణి సార్. సార్
సార్ ఉన్నారు.
అదే సార్, గుడ్ ఈవినింగ్ సార్. ఏం సార్ విశేషాలు? అదే
పీపుల్ ఆర్
హలో హలో
సార్. గుడ్ ఈవినింగ్.
హలో
సార్.
హలో
ప్రసన్న
చెప్పు.
ఆడిబిలిటీ క్లియర్గా ఉంది కదా? ఆడిబిలిటీ క్లియర్గా ఉంది కదా?
వినిపిస్తాను.
ఓకే రైట్. రికార్డింగ్ స్టార్ట్ చేస్తున్నాను.
Yeah, you can address the participants and if
this conference will now be recorded.
ఒక 2 minutes చూద్దాం ప్రసన్న. 4:06 అయింది. ఒక 2 minutes చూసి స్టార్ట్.
ఓకే
రైట్. హలో ప్రసన్న. హలో.
విఠల్
ప్రసన్న
విఠల్
అదే సార్.
విఠల్ మ్యూట్లో ఉన్నాడు.
ఓకే ఓకే రైట్ సార్, ఇంకా స్టార్ట్ చేద్దామా సార్? అదే సార్.
చేయండి.
రిసోర్స్ పర్సన్
అదే యాక్చువల్ మేడం ఇంట్రడ్యూస్ చేస్తారంట. యాక్చువల్ మేడం చేస్తారు, వచ్చినట్టున్నారు జాయిన్ అయ్యారు.
రాజేంద్ర ప్రసాద్ సార్ ఈజ్ నాట్
ఓకే ఐ విల్ ఇన్ఫార్మ్. పంపించాను సార్, సపరేట్ మెయిల్ ఐడి పంపించాను ప్రసన్న సార్ పంపించాను.
ఓకే ఓకే ఓకే
మెయిల్ ఐడి
ఓకే ఓకే ఐఎమ్ జస్ట్ రిమైండింగ్ యూ.
ఓకే రైట్. ఒక్కసారి నేను సార్ కాల్ చేసి చెప్తాను.
దట్స్ వాట్ ఐ నీడ్.
ఓకే
అయితే అయితే ఏం జరుగుతుందంటే రోజుకి రాడిస్తే అన్ని జంతువులకి వాటి పిల్లలు కనపడరు. కాకపోతే సింహం అనేది ఉంటుంది, కొన్ని రోజులు కాన్సర్ కనపడుతుంది. అయితే ఒకసారి అడవిలో జంతువులు ఉండే కాడికి ఆకలితోని ఒకసారి ఆయన కాడికి వెళ్ళి చూసి చెప్తుందంట, సింహరాజు చాలా కోపం ఉంటాడని చెప్తాడంట. అయితే ఏం చెప్తాడంటే తర్వాతకి
విఠల్ విఠల్ విఠల్
అన్ని జంతువులతో ఎంజాయ్ చేస్తారు.
రమ్య ప్లీజ్ మ్యూట్ యువర్ మైక్. చెప్పండి.
మ్యూట్ ఆల్.
మీరు అట్లా యాక్టింగ్ చేస్తారు. అయితే
చేస్తాను నేను. యాస్మిన్ మేడం, యూ కెన్ స్టార్ట్ మేడం.
Yes, Bitan sir. Can I address the participants?
Yeah.
Good evening, one and all. On behalf of AC Department, GPRC Kurnool, I W. Yasmin, Assistant Professor, welcome you all to the Day 2 webinar on present trends and research scope in 5G wireless communications. I take it as a privilege to introduce today's resource person, Dr. M.V.R. Vittal garu. Dr. M.V.R. Vittal is currently working as Associate Professor, Department of EC, G. Polarity Engineering College, Kurnool. His areas of interest are wireless communications and signal processing. He published various research papers in various international and national journals and conferences. He is a reviewer of IEEE transactions on communications and SN Applied Sciences, Springer journals. He is a senior member of IEEE, fellow of Institution of Electronics and Telecommunication Engineers, and lifetime member of ISTE. We are fortunate enough to have an eminent personality like him as the resource person of today's webinar. Now request Dr. M.V.R. Vittal garu to take over the session. Thank you one and all.
Thank you, madam. Thank you for introduction. Right. Good evening, everybody. Good evening, all. I request all the participants to once again mute your mic. And I will be handling the session today. Yesterday, Dr. Rajendra Prasad sir has handled a session about basics of wireless communication, concepts of wireless communication, and introduction about some 5G concepts. now I will be continuing to more focusing on 5G concept. Before that, I will briefly introduce about the advantages of wireless communication. Then we will go in for 5G concept. Right. Is it audible to all of you? This? Is my voice audible to all of you?
Yes, sir, it's clear, sir.
Okay, right. Are the slides visible to all of you? Are the slides visible?
Yes, yes.
Okay, is the screen okay? Right. So there is some background noise. Please mute your mic. All the participants, I request you once again. Please don't unmute. Please mute your mic. Right. So let us continue the 2-day webinar on present trends and research scope in 5G wireless communications. Myself, Dr. M.B.R. Vittal, working as Associate Professor in the Department of ECE, Deep Engineering College, Kannur. So today outline is important. First we discuss about importance of wireless communication, features of 5G technology, OSI modern architecture of 5G, prominent 5G technology, what are the prominent 5G technologies, concept of small cells in 5G, and what are the various 5G technical challenges, research scopes in 5G wireless communication. So coming to the brief introduction about this history of wireless communication, Alexander Graham Bell demonstrated the telephone wire first in 1876, and in 1880 Bell used reflective sunlight and photoelectric detector to transmit without wire intelligent speed over 700 feet. Henry Rudolph Hell demonstrated the existence of electromagnetic waves in the mid-19th century. And Rudian G. Marconi received a patent for first practical wireless telegraph, awarded a Nobel Prize in Physics in 1909. Why we are going for wireless? Why wireless has become so prominent? So the technologies are mostly used in radio transmission, new protocols for data transmission are needed. And what is the importance of this? Spatial flexibility in radio reception range, ad hoc networks without formal planning. Ad hoc networks need no establishment. All of you know that. Ad hoc networks can self-align themselves. They don't require any establishment. And no problems with wiring, historical buildings, fire protection, etc. Suited for long-distance communication, robust against disasters like earthquake, fire, etc. Mobility. Wireless communication network is a solution in areas where cables are impossible to install. Maybe example, hazardous area, long distances, etc. Easier to maintain. So these are all the advantages of this wireless communication. This is the basic block diagram of a wireless communication system. Whatever the wireless communication you get, this is the basic diagram. This represents the transmitter portion, these three blocks, that is coding, modulation, transmitter, this represents the transmitter portion. And here you are going to see the receiver portion, that is receiver followed by demodulation process, decoding, then the recovered data stream. In between you have a wireless channel, or it's called as RF propagation channel, the transmitting antenna. So this is the most common wireless communication system block diagram. Maybe analog or digital, whatever it is. Basically, if you go to the one more cellular concept is an inbuilt concept of wireless communication. Actually, it's a part of wireless communication. You can see that. So it is going to use the hexagonal shaped cells. It's going to use frequency reuse scheme. The frequency reuse scheme is generally used to increase the capacity. So in the use of one more frequency, same frequency in other cells. Actually, if you take one cell, if you are going to use the same frequency in other cell also, then it is called as frequency reuse, that is which increases the capacity of the system. So why hexagonal shaped cells are very important? Because it almost forms a circle. It forms almost a circle. It covers the area of a circle, and also there is no overlapping. That's why the cellular system design engineers actually designed the cellular pattern in the form of a hexagon. That is the importance of using the hexagon. And the capacity and the frequency spectrum and the spectrum efficiency are the key factors. Capacity of the system is more, and spectrum efficiency, it is how efficiently use the spectrum without any interference. That is called as spectrum efficiency. So there's one of the key factors. And if we're going to follow frequency management and channel assignment, it's going to follow the frequency management and channel assignment. These are the two important factors in cellular and mobile communication. And one more feature is it is going to incorporate handoff feature. Yesterday, as a resource person, Rajendra Professor discussed, 2G, the basic feature of 2G is handoff actually. So 2G has gained more prominence over 1G because of this particular handoff feature. 1G had no handoff feature, but when it comes for 2G, it has handoff feature. Handoff feature is nothing but handovering of a mobile station from one base station to another base station. Handovering of a mobile station from one base station to another base station is always called as handoff feature. So 2G has become more prominent. The subscribers who are in just thousands, they will jump to millions when you came for 2G technology. That is the importance of 2G. So that is the revolution that 2G, that GSM has created from 1G. 1G was completely analog. When you come for the 2G, it has become digital. So that is the importance of this particular 2G technology.
ఏంటది?
All the basics of wireless communications and why we are going to employ this wireless communications. And yesterday already Sir discussed about the evolution of wireless technology
వైట్ వైరీగా
from 1G to 5G. Now we are
Right,
going
right.
to see the comparisons performance of, starting from 1G to 5G. So starting from 1G, which was introduced in 1980s, the data bandwidth of 2 kbps, standard is AMPS was there. America, this advanced mobile phones.
ఆ వైర్ కూడా చివర కూడా ఇచ్చారు.
Analog, cellular, completely analog and cellular.
చార్జర్ వైర్.
2G, the data bandwidth is 64 kbps. It was introduced in 1992. And the standards that are there are TDMA, CDMA, GSM, GPRS. GPRS stands for GPRS 2.5G. It is more near to 2G, and it is completely digital and cellular. When you come for 3G, the data bandwidth is 2 Mbps. That is CDMA, wideband CDMA is used. Broadband with CDMA, IP technology. So these are the technology that is used. Of course, the switching, when you come for the switching, 1G was using circuit switching, and 2G was using circuit and packet, and 3G was using completely packet. When you come for the 4G next column, data is 200 Mbps and single unified standard and unified IP internet protocol and seamless combination of all things. And it is all packet based, all the packets. And when you come for 5G now, this 2020s, late to the 2010s or early 2020s, actually 5G should have been launched now itself, but now due to some constraints, it is still taking some time to launch. But almost many research is going on in particular 5G technology. Many research is most of the vast research is going on in 5G. There is just a vast scope for research in this particular 5G technology. And the data rate is the 1 Gbps, signifies single unified standard, IP and seamless combination. That is all packets. Those are the features of 5G technology. 5G technology refers to the short name of fifth generation, which was started from late 2000. Complete wireless communication with almost no limitations. It is highly supportable to www, that is wireless World Wide Web, and has high capacity and high speed. 5G technology provides large broadcasting of data in Gbps and faster data transmission than that of previous generations. Large phone memory, dialing speed, clarity in audio, video, supporting interactive multimedia, voice, streaming, video, internet, and other advantages. So these are all the advantages of this particular features of this particular 5G. So the speed is expected up to 1 Gbps, more faster and reliable than 4G, lower cost than previous generations, both cellular and broadband services everywhere, high performance, and easy global. And these are the important features of most important features of 5G. 5G was providing it is consuming low battery, power, cheap, it is economical, multi-user memo. It is having strong bandwidth and better coverage. These are the advantages of this, features of this 5G technology.
గంట వరకు ఏం తెలియకుండా చేసేస్తాను.
Hello, the participants are requested just to mute the mic. All the participants are once again requested. Prasanna.
Karnakar.
Vital, you can mute all.
Sir,
Vital, mute all.
we can complete. We can continue, sir.
Everyone is muted. You carry on.
Okay.
Everyone is muted. You carry on, Vital.
Okay, right. Right. The key characteristics of 5G technology, they include the wearable devices of the capabilities, Internet Protocol version 6, where a visiting care of mobile address is assigned according to location and connecting network. One unified global standard, dynamic ad hoc wireless networks, essentially identical to mobile ad hoc network, wireless mesh network or wireless bridge combined with smart antennas, cooperative diversity and flexible modulation. User-centric network concept instead of operator-initiated. Worldwide wireless web, a comprehensive wireless web-based web applications that include full multimedia capability beyond 4G speed. So these are the characteristics. And of course, the commutative radio technology, also known as smart radio, allowing different radio technologies to share the same spectrum efficiency by adaptively finding unused spectrum. And of course, you also know about commutative radio, the basic definition of commutative radio. Commutative radio is an adaptive intelligent radio network that can automatically detect available channels in a wireless spectrum and change the transmission parameters that enables more communication, more reliable communication. Right. And so this is so it supports the commutative radio and software-defined radio also. Software-defined radio is a radio communication system where components that have been traditionally implemented in hardware like mixers, filters, etc. are implemented by means of software like on a PC or embedded system. This is software-defined. So 5G technologies are completely supporting this particular commutative radio and software-defined radios. And adapting the transmission scheme to the requirements of technology currently sharing the spectrum. This dynamic radius is resource management is achieved in a distributed fashion and relies on software-defined radio. And a major issue for beyond 4G systems is to make the beyond 4G systems means it is 5G. A major issue in beyond 4G systems is to make the high bit data rates available in a large portion of the cell, especially to users in a exposed position in between several base stations. In 5G systems, this issue is addressed by cellular repeaters and macro diversity technique, also known as group cooperative relay. Let's know about the diversity. Diversity actually is the technique that the best solution to fading. Fading is a disturbance or it's the oscillate itself as it propagates from transmitter to receiver due to the multi-part propagation. So this is going to employ the macro diversity technique. Remote management, better and fast solution, high uploading and downloading speed, more effective and extraordinary data capability. It offers high quality of service due to high error tolerance and offers global access. It offers high quality of service is very important. While providing quality of service, one more parameter you have to check is link reliability. What is the link reliability that is available? That is also you have to check. How much reliability the link is without having the internet. That is the thing that you have to check. This particular OSI model of this 5G network, this figure compares the OSI stack with the 5G network stack. At the first, as you know that there are 7 layers: physical layer, data link layer, network layer, transport layer, physical layer, presentation layer, and application layer. In 5G stack, actually these tools are combined. Physical and data link are combined as open wireless architecture. And network layer is the network layer with an upper network divided into upper network layer and lower network layer. And one more, transmit layer and session layer are combined into open transmit transport protocol as OTP. And presentation layer and application layer are combined into applications of service. So these are the layers in the different layers that are present in this particular 5G network stack. And coming to the architecture of this particular 5G technology, you have got all the base station interconnections, and it is implementing beamforming techniques. It's trying the 5G, this regular communications, mobile to mobile communications, multi-hop communications, direct mode communications. It is going to share the spectrum, but simultaneously it is doing all the things. Simultaneously it is doing all the things. Depends on simultaneously it is controlling all the things, and then doing. So RAT stands for random access technology. Sorry, radio access technology. Right. So simultaneously it is concentrating on everything. The main advantage is it has high bit rate. The high bit rate, and it should be economical, and also the interference should be minimal. These are the key features, key aims that have to be followed. High quality of service must be there. High bit should simultaneously should generate more bit rate, and interference must be minimum. That is it. And when you compare, brief comparison between antennas that are used in 4G and 5G antennas, you can see that they are more directional. You can see that 5G antennas are more directional compared to the 4G directional. They are more directional and more efficient. Coming to this, before coming to the 5G technology, let us have a brief recap of what is meant by OFDM and MIMO OFDM. So OFDM, all of you know, is orthogonal frequency distribution multiplexing. It's a 4G supporting technology. It is very prominent used in many vast applications it is used, and many risks are going on also in this OFDM and MIMO OFDM. So OFDM provides always a robust solution to frequency selective fading. So fading, already I told you, it's a cause of signal oscillation or signal disturbance, or the signal moves from transmitter to receiver due to the multi-pass fading. And the division into narrow band subcarriers. OFDM divides into narrow band subcarriers. Spectra overlap, but signals are orthogonal. Here the spectra is going to overlap, but the signals are orthogonal to one another, thus providing almost zero interference. It is provide zero interference. And the OFDM robust solution to selective fading. Of course, come for the MIMO OFDM. MIMO OFDM combination of MIMO OFDM with OFDM is still more beneficial because it is going to use multiple antennas for the transmitter. Actually, there are got 4 configurations: CISO, SIMO, MISO, and MIMO. CISO stands for single input, single output. SIMO stands for single input, multi output. MISO stands for multi input, single output, and MIMO stands for multi input, multi output. So out of all these things, MIMO is more beneficial out of all these combinations. So it is also a 4G technology, MIMO FTM. So it's more beneficial, which is going to employ spatial diversity, which is very important, and spatial multiplexing. These two are the key features in this MIMO FTM. We are going to discuss about this shortly. What is the spatial diversity and spatial multiplexing? Going to improve the capacity of the system. And coming to the block diagram of this OFDM transceiver, we are going to see what are the important blocks that are there. Modulator, serial to parallel converter, IFFT block. IFFT is the inverse phosphorate transform. All of you know the FFT algorithms, which are used to compute the DFT of a sequence at a faster rate. FFT algorithms are used. It is divided into 2 types: radix to DIT FFT, radix to DIS FFT. It is used to compute the DFT of the sequence at a faster rate. So IFFT is used to convert the frequency domain symbols incoming into time domain symbols. Then once again parallel to serial conversion. After cyclicity. So cyclicity is always direct to combat ASI. You have to remember that intersymbol interference is more significant in the digital communication, in wireless communication also. So you have to add before the data bits, you have to add the cyclicity. So that cyclicity length should be always greater than delay spread. So how to define delay spread? Delay spread is nothing but when you transmit a mobile, base station, when it reaches the receiver, it's having the pulse is small spread. Generally, the cyclicity is generally designed to be larger than the delay spread. Okay? Then digital to analog converter before going to transmitting the transmitting antenna. So you have to go to the RF front end, then wireless channel, Then on the receiver side, ALD converter, remove the cyclic break, all these operations, whatever the inverse operations that are there transmitter side, those operations must be performed. Serial to parallel converter, FFT. Since you are already converted in time domain, once again FFT has to be there. So FFT, P by S, P by S. So why I am telling about this OFDM diagram, because you should be very thorough about this OFDM diagram before you go to the 5G, because 5G is an extension of this particular. So in 5G, you have got, suppose for example, let us say massive MIMO OFDM is a 5G technology. So before going to that, you should know what is this particular MIMO OFDM. Okay? Before OFDM, you should know this OFDM. So OFDM is the basic of this, so I am discussing this. So last time was MIMO OFDM system. So already I told you that whenever OFDM is combined with the MIMO system, it is still more beneficial. It is also a 4G technology. MIMO OFDM is also a 4G technology. Especially the difference is that you are going to employ large number of antennas, both at the transmitter and at the receiving end. So that is called, that's why it is called as this. Okay? So you are taking the input bit stream, then you are going to use the channel coding. So channel coding, you have got many linear block codes, convolution codes, you are going to use the channel coding. Then using the MIMO encoder, you are going to transmit to the OFDM modulator, which is having the transmitting antenna. So at the receiver side, you are having the demodulator section, which is going to reconnect the signals, okay, OFDM to the OFDM demodulator, followed by the MIMO decoders, channel decoders, and the recover streams. So all these are the operations that are there at the perform of the receiver. So it is just a combination of multiple antennas for the transmitter and receiving portion with MIMO. Right. Now let us talk about what are the different 5G prominent technologies that are available. The prominent 5G technologies that are available are massive MIMO is one thing, non-orthogonal multiple access called as NOMA, and generalized frequency division multiplexing. These are the prominent technologies. Of course, there are still many some other technologies also there. Because of lack of time, we'll be discussing about the most important thing. This massive MIMO, non-orthogonal multiple access, and generalized frequency division multiplexing. Coming to massive MIMO, what is this massive MIMO? Massive multi-input, multi-output, or massive MIMO is an extension of MIMO, which essentially groups together more antennas at the transmitter and receiver to provide better throughput and better spectrum efficiency. You know the difference between throughput and output, right? Throughput is the number of packets or number of data bits that are delivered successfully without any collision. That is called as throughput. Okay? Right. So it is going to employ more number of antennas at the transmitter and receiver to provide better throughput and better spectrum efficiency. Spectrum efficiency is the efficient use of spectrum without any interference. So makes use of spatial diversity, spatial multiplexing, beamforming. These are the very, very prominent techniques that you should be thorough. This should employ spatial diversity, spatial multiplexing, and beamforming. Aiming at improving the reliability of the system, we choose to send same data across the different paths. This is called as spatial diversity. Okay? Aiming at improving the reliability of the system, we choose to send same data across different paths. Okay? If one antenna, the receiver side, different receives a deep wave, there is no guarantee that other antenna should receive strong signal. The probability of other antenna also receiving the is less. That is the diversity technique. You are going to have a spatial separation of the antennas at the receiver side. If one antenna receives a deep wave, the other antenna definitely receives a strong signal. That is the concept. The other antenna definitely receives a strong signal. So it is going to avoid the fading. So diversity is better solution to the fading concept. Right. So spatial concept, spatial multiplexing, often abbreviated as SM or SMX, is a transmission technique in MIMO or wireless communication and other communication technologies. It transmits independent and separately encoded signals known as streams. Therefore, the space dimension is reused or multiplexed more than one time. So this is called as spatial multiplexing. And if you are seeing this particular massive MIMO system, configuration of massive MIMO, so having more number of antennas here and large antennas to increase cell throughput. Large number of antennas you are employing basically and reduce out of cell interference. You are going to see, observe that you are going to see reduce out of cell interference. When you can go for the other cells, so the probability of other cell interfering with particular thing is less. So that is why it is going to. Massive MIMO technology is one prominent technology, that is 5G technology. Beamforming, next is coming to the beamforming. Beamforming is a technique that focuses on a wireless signal towards a specific receiving device rather than having the signal spread in all directions from a broadcast antenna. So beamforming is a technique that focuses on a wireless signal towards a specific receiving device rather than, so actually you are going to focus the signal, suppose you are aiming at one receiver receiving end, you are going to focus the signal at that particular thing and you are going to eliminate or you are going to reject the other direction. So it's beamforming concept is very important. The resulting more direct connection is faster and more reliable than it would be without beamforming. Adaptive beamforming is used to detect and estimate the signal of interest at output of sensor by means of optimal spatial filtering and interference detection. The improvement of beamforming is called as adaptive beamforming. All of you know about adaptive filters. Adaptive means it should adjust to any environment. That is called as adaptive in nature. So adaptive filter is going to gives an adaptive signal, widely used in adaptive signal processing algorithm and also in this wireless communication also. Right. So it is used to detect and estimate the signal of interest as output of the sensor array by means of optimal spatial filtering and interference detection. Next, coming to the non-orthogonal multiple access technology, non-orthogonal multiple access or NOMA. NOMA is fundamentally different than the multiple access schemes which provide orthogonal access to the user, either in time, frequency, mode or space. In NOMA, each user operates in the same band. At the same time, they are distinguished by their power level. NOMA uses superposition coding. This is very, very important concept. NOMA uses superposition coding of the transmitter such that the successive interference cancellation receiver can separate the users both in uplink and in the downlink channel. We will just see what is meant by this particular successive interference cancellation channel in the next slide. NOMA was proposed as a candidate radio technology for 5G wireless communication systems. Okay, so it is going to employ superposition coding of the transmitter such that the successive interference cancellation that the receiver can separate both the signals in uplink and downlink domain. Superposition coding of the transmitter and the successive interference cancellation receiver makes it possible to utilize the same spectrum for all users. Yes, superposition coding of the transmitter and the successive interference cancellation receiver makes it possible to utilize the same spectrum for all users. You can see this particular successive interference cancellation phenomenon here in this particular thing. The base station is assumed to going to transmit the two users, and suppose you consider user 1 or particular user 1, you are going to subtract user 2 signal such that you are going to have only this particular user 1's signal to decode. Like that, the process is repeated until otherwise you get all the desired signal, and the process is repeated until otherwise you get all the desired signal. Next, coming to the benefits of NOMA. It achieves superior spectral efficiency by serving multiple users at the same time and with the same frequency resource and mitigating the interference through sightseeing. It increases the number of simultaneously served users and thus it can support massive connectivity. There is massive connectivity, there is large number of huge amount of connectivity is there, that is called as massive connectivity. Due to the simultaneous transmission nature, the user does not need to go through a scheduled time slot to transmit this information. And hence it experiences lower latency, which is very important. Latency means that it is a delay. Latency means it is a delay. So due to the simultaneous transmission nature, the user does not need to go through the scheduled time slot to transmit its information. Okay, because of the simultaneous transmission nature, it need not wait time. So it experiences lower latency. NOMA can maintain user fairness and diverse quality of service by flexible power control between a strong and weakened user. So it can clearly distinguish between the strong and weak users by using the particular power control. Okay? You can maintain the user fairness and diverse quality of service by using flexible power control between the strong and weak users. NOMA offers higher cell edge throughput, thus enhances the cell edge user experience. So NOMA is going to offer higher cell edge throughput. So when you are going to the cell edge, actually due to the far end and near end interference problem, generally the signal will be weaker at the cell edge. So it's going to concentrate more on cell edges. When you go take the rectangular cell pattern, going to concentrate more on cell edges. So it's going to offer higher cell edge throughput, thus enhances the cell edge user experience. Next technology is GFD, that is called as the generalized frequency division multiplexing. So generalized frequency division multiplexing is a flexible, non-orthogonal multi-carrier modulation scheme proposed for 5G physical layers. Benefiting from its time frequency block-based modulation structure, GFDM exhibits several advantages over orthogonal frequency division multiplexing, such as higher spectral efficiencies, lower out-of-band emission, and flexibility of the system configuration. So what is meant by this out-of-band emissions? Out-of-band emission immediately outside the necessary band, called as out-of-band emission. So it's called as out-of-band. So the frequency components which are there immediately after the outside the necessary bandwidth is called as the out-of-band emission. So higher spectral efficiency, the spectrum must be properly spectrum is a scarce resource. Actually, all of you remember the spectrum is a scarce resource which must be carefully utilized, and it should be properly utilized without any interference. So the spectrum must be efficiently utilized. That is very, very important. So all these factors are the flexibility of the system configuration. Enables a block-based transmission using cyclic insertion and efficient FFT-based equalization. So generally, it is going to receiver side. The equalization techniques are performed generally at the receiver side. Equalization techniques are performed generally to compensate for the effects of channel. That is the importance of equalization technique. We come across that when you go shortly. We come across that equalization technique. So there are many equalization techniques that are there, linear, non-linear equalization techniques. You have to remember that equalization techniques are always used for the receiving end to compensate for the effect of the channel. So if you are going to FFT-based equalization is at the receiver side, you are going to perform this. After the FFT, after the FFT, you are going to perform this equalization. GFDM enables frequency and time domain multi-user scheduling comparable to OFDM. Okay? Multi-user scheduling is multiple users can simultaneously share the subcarrier. It's called as multi-user scheduling. Multiple users can simultaneously share the subcarrier. Sharing of this is called as that. So this is a block diagram of this particular GFDM transceiver system. So necessary, so you can see that this is having synthesis filter bank at the transmitter side and analysis filter bank at the receiver side. So coming to the synthesis filter bank, the synthesis filter bank is having upsampler block. Okay, it is sampled by upsampled by sampling factor of n. So what is meant by upsampling? Increasing the sampling rate by factor of n. It is called as upsampling. So it is going to increase the sample rate. So the data bit increases the sample rate. After the circular convolution is employed, because circular convolution is going to have less complexity compared to linear convolution. That when you employ circular convolution, is having less complexity. Okay. So that's why the service are, and also you can rotate the sequence, you can wrap the sequences, and then whatever the operation is there, you can perform that. You can circularly rotate the sequence, circularly shift the sequences. All this is possible with the help of the circular convolution. You are all doing within the form of structure, and the structure you are all doing. So you are studying signal processing, so you can take the circular convolution. Okay? So then followed by this e power k 2 pi by n factor. We are saying this e power j 2 pi by n. E power j 2 pi by n factor, whenever you are having this positive exponential, always it means IFFT. Remember that? It is always IFFT. It is multiplied by a factor of e power k 2 pi n. All of you know the formula for IFFT. X of k into e to the power j 2 pi k n by n. Okay? X of n is given by 1 by n into sigma k equal to 0 to n minus 1. X of k into e to the power k 2 by k n by n. So positive exponential you are going to is that you are using the IFFT. That means the frequency domain symbol you are going to convert into time domain symbol. In the same manner you are going to add the cyclic prefix here. You are going to pass through a wireless channel. Then on the receiver side you are using this cyclic prefix removal followed by frequency domain equalization. FD stands for frequency domain equalization. Okay? And appropriate channel estimation parameters are there. So channel is a crucial part of this wireless communication where noise and interference comes into picture. So you have to carefully design the channel such that no noise and interference are there. But carefully design the channel such a way that no noise and interference comes into picture. So this and once again you are going to at the receiver side, you are going to employ this FFT, e power minus j 2 band factor. E power minus j 2 band factor means that you are working with the FFT block followed by circular convolution. Finally, you are going the decimation. That is downsampling process. Decreasing the sampling rate. You are going to decrease the sampling rate by a factor of n. And finally, this you are going to recognize D0 hat, D0, D1 hat, Dn minus 1 hat. This has means that it is expected thing, okay? Because of this corrupted by noise, exactly you cannot remember recover the signal. This is the nearly approximate symbols you are going to remember. Okay? Suppose that sometimes if noise is removed, you can exactly recover the symbol. So this is the block diagram of this particular GFDM. So GFDM is a strong candidate to the 5G wireless communications. Nowadays, a lot of research is going on with particular GFDM. And after this prominent 5G technology, there is one more prominent the concept, that is the concept of small cells in 5G. What are these small cells in 5G? Small cells make use of low power, short range system that covers small geographical areas or small proximity indoor and outdoor spaces. See, in some applications, 5G, even though 5G is very powerful, the 5G signals cannot penetrate inside the indoor environment. Suppose you are sitting in an office somewhere in a multi-storied building, inside the office you are sitting, and you want the signals properly to be received. So that cannot be possible. So there you are going to make use of small cells. You're going to cover small geographical areas and small indoor and outdoor spaces. Small cells have all the same characteristics of the classic base stations that have been used by telecom companies for years. However, they are uniquely capable of handling high data rates for mobile broadband and consumers, and for IoT, high densities of low speed, low power devices. So it is also used in IoT. This concept is also used in IoT. All of you know Internet of Things. A lot of projects and lot of research is going on in IoT. This feature makes them perfect for the 5G rollout. Promises ultra high speeds, a million devices per square mile, and latencies in the millisecond range. Small cells work exactly similar to conventional cell concept with advanced techniques like MIMO, beamforming, and millimeter wave for travel. One more technology, prominent technology, 5G technology is millimeter wave propagation. So that is also done. So low power transmitting stations can be easily deployed using the small cell concept. Moreover, small cell hardware units are designed to reduce complexities, and the implementation is faster and easier. So low power transmitting stations can be easily deployed using the cell. So if the transfer requirement is less, become lesser here because of the installation of this particular small cell. These small base stations, transceivers are wall mountable for indoor applications, and many of the small towers or lamp posts are outdoor. The backhaul connections are made with fiber, wired, and microwave connections, making configuration less complicated than the previous. One thing you have to remember in this particular wireless communications, you have to concentrate on complexity also. See, 5G, when you go for the 5G, it has got a lot of complexity. So, you have to compensate for this particular complexity also. You have to minimize the complexity. For that, it is there. The backhaul connections are made with fiber, wired, and microwave connections. The concept is that you are going to divide the macro cells into small cells, such that the connections are more reliable, high data rate, and less interference. So coming to types of small cells, there are three types of small cells in the industry: femtocells, picocells, and microcells. Each is distinction based around its coverage capacity and the number of individual users. Coming to femtocells are small mobile base stations that help extend coverage for residential and enterprise level applications. These are mainly used to offload networks when they are congested, extend coverage. So the offload, what is this offload network generally? Meaning that generally during the network congestion, whenever net is slow, 3G or 4G network shift the traffic to Wi-Fi. Okay? This is done without users notice, which is called as offload network. So these are mainly used to offload networks when they become congested. Okay? So they extend coverage and enhance reading penetrations for indoor consumers. So coverage area is around 30 to 165, and then milliwatts of power, supports the JCC, backhaul, and low power. Picocells are there. So a picocell is another type of small cell technology. The small cellular base station typically covering a small area such as in building or more recently in aircraft. Picocells are great for applications in offices, hospitals, shopping complexes, schools and universities, mainly small enterprise for extended network coverage and large route data feed. So coverage area is 330 to 820 feet, 250 milliwatts, suppose it's backhaul, low cost. And coming to microcells, last configuration. The microcell is a cell in a mobile network powered up by a low power base station that covers a limited area such as malls, hotels, unique spaces within small cities or transportation hubs. Microcells are generally more substantial than a picocell, though the distinction is not always clear. The microcell can support a more than significant number of users in unique geographical areas. So these are all the features: coverage area, 2.8 power, simultaneous users, backhaul is wide, fiber and microwave, medium cost. Okay, they are medium cost, more expensive than this term, but is having more advantage. So the intent of using the small cells is alleviate the load on macro cells, that is large cells, by augmenting the network capacities and provide extended coverage. Use of small cells is limited to dense areas and indoors, that is where macro signal penetration is inadequate. Where macro signal, whenever there is macro cell penetration is inadequate, we are going to use this particular macro cell. So this is exactly the diagram of this micro cells, showing the micro cells, stem cells, and so macro cells is generally outdoor, suitable for outdoor, that is large cells. Coming to the three classifications we have seen: stem cells, picocell, and micro cells. Stem cells is indoor, picocell is outdoor or indoor, micro cell is completely outdoor, can be used outdoor or indoor. Okay? You can see that the power gradually reduces length. Coming from macro, micro, pico, and this, and the power is going gradually reducing. So key concepts of 5G, these are the key concepts of 5G that this is going to cover all the features. So it has a massive MIMO technology is going to use relay to relay communication, millimeter wave and terahertz communication, LTE advanced, LTE and Wi-Fi integration is there, and here we are going to have the heterogeneous network, okay? And massive machine type communication. Okay? Heterogeneous networks are networks connecting computers and other devices where OS and protocols are different. Okay? It is going to the network connecting computers and other devices where OS and protocols are different. Massive machine type communication is a fully automated data generation, exchanging the processing without intervention of human. So fully automated data generation, exchange and processing of data without intervention of humans is called as massive machine type communication. All these features are there in this concept of 5G. Now coming to the technical challenges, what are the technical challenges that are there in the 5G technology, design of 5G technological engineers, they have to know about this the challenge. So building complex and dense network, 5G networks will be significantly more complex than current network. One component of this is the increasing complexity, the need for sensor network. New 5G antennas and RAN hardware, although powerful, RAN stands for radio access network, is going to connect individual devices to other parts of the network through radio connection. Okay? That is random access. So all the powerful cover significantly less space compared with existing 4G macro network. This means similar coverage requires more 5G hardware and supporting software, a number that multiplies further traffic moving growth. So first concept they have to remember is building complex and dense network. So while building that, you have to see that complexity is pretty less. So next is keeping operating and maintenance costs low. Having the necessary hardware required for 5G network can significantly increase operating expenses. Of course, this cost goes beyond the hardware itself. Networks must be configured, tested, managed, and regularly updated. All things that exponentially increase this cost. So this you have to take into account the cost also in consideration. Meeting low latency requirements. While not critical for telecom applications, it is needed for emerging market of devices that can allow that can allow a single millisecond of for one-way communication across the disconnect. Okay? So this low latency stands for delay. So we have low delay. So generally, if you delay that more number of users are there, you can expect simultaneously expect more delay. So for telecom applications, is needed for that allow only a single millisecond of delay for one-way communication across the entire infrastructure. Dealing with new security issues, that is very important. Right? So prepared more security and authentication purposes are there. Every new technology comes with new risk, that is, and 5G is no exception. Given the highly distributed, connected, and sometimes remote nature of 5G network, new consideration must be given to potential security and authentication issues. Because authentication is very, very important. Authentication to security, so using the robust cryptographic algorithms is also one of the important points in this particular 5G technology. It's highly secure. So the 5G communication design engineers must consider the factors of low complexity, hardware and software, low latency, delay, robust authentication and security, and at the same time make the system economical, that is affordable. So these are all the things that I would consider. Coming to research scope in 5G communication, research scope in 5G wireless communication. So wide and vast research is going on current wireless communications to improve the performance, quality of service, link reliability, etc. Some of the important research problems which can be focused in wireless communication by our EC people are. So first is interference cancellation. Interference cancellation is a major research challenge that must be focused. So ICA and ISI, SIC, intra-carrier interference, inter-symbol interference, self-interference cancellation, etc. Peak to average power ratio reduction, PAPR reduction is also very important there. Also it's implemented in 14. It is also a research scope, important research scope in the 5G technology also. Carrier frequency offset estimation, efficient channel estimation and equalization technique, green communication. This is one more feature that is added as green communication. Okay. So coming to successive interference cancellations, many works are going on in successive interference in 5G communications. The receiver first detects the signal sent by the first user, and after successful detection, it cancels the interference contributed by the detected signal before it detects other user signals. So the receiver is going to detect the signal first by sending by the first user, and after successful detection, it is going to cancel the interference contributed by the detected signal before it detects the other user signal. The process is repeated until all the user signals are detected. We have seen this in massive memo. Already we explained about this particular successive interference cancellation. ICA and ISA are also important to be considered. ICA generally occurs due to loss of orthogonality between subcarriers. Whenever loss of orthogonality is there between the subcarriers, this ICA is there. ISI is occurs whenever this cyclic difference is there, the standard relay spread. The symbol interference. The signals are going to overlap. Such that the identity of the original signal is lost. And this SIC is widely implemented in NOMA. This SIC, successive interference cancellation, is widely implemented in NOMA. And high PAPR reduction, peak to average power ratio reduction. So what is this PAPR? PAPR occurs due to the summing of carriers together. The peak power increases proportional to the number of subcarriers. PAPR is expressed as is equal to maximum of S square of t divided by expected value of S square. Test of the signal. Then expectation of this S square of t indicates the peak signal power and maximum power, and expectation of this indicates the average signal. So this the high PAPR always increases the complexity of A to D and D to A converter, reduction in efficiency of power amplifier, and high PAPR reduction in 5G systems is also a good research scope. So we have to remember that it increases the complexity of A to D converters, reduction in the efficiency of power amplifier. One more research challenge that must be focused on this the carrier frequency offset. So what is this carrier frequency offset? The orthogonality among subcarriers is maintained only if the receiver uses a local order signal that is synchronous with the carrier signal contained in the receiver. The orthogonality among the subcarriers is maintained only if the receiver uses the local oscillator signal that is synchronous with the carrier signal contained in the receiver. If you consider the system use orthogonal subcarriers for communication, this offset destroys orthogonality and causes inter-carrier interference. So the carrier frequency offset must be carefully compensated, must also carefully considered. It occurs a mismatch whenever of the carrier frequency. So algorithms with low compression must be designed to compensate the carrier frequency offset in 5G systems such as GFDM, that is general frequency division, generalized frequency division multiplexing, and non-orthogonal multiple access, NOMA. Okay? The concept of this NOMA is that in the OFDM, all the subcarriers you can expect is orthogonal. So sometimes practically it cannot be possible that all these subcarriers are orthogonal to each other. So this NOMA concept exploits this nature, and then it is going to have this non-orthogonal, even though these are non-orthogonal also, then the same performance must be there. That is the advantage of this particular NOMA. And efficient channel estimation and equalization techniques. Efficient channel estimation and employing proper equalization techniques has a good research scope in 5G systems. So channel estimation is a crucial parameter because channel is crucial entity where noise and interference get added up. Channel parameters such as channel impulse response, frequency response must be carefully estimated. Because it's a wireless medium, when a signal is propagated through a wireless antenna to the wireless medium. So the estimation of channel is very important because channel is going to be corrected with noise and interference. Equalizers compensate for the effect caused by the channel. So the main advantage of equalizers is they are designed as a receiver, mainly to compensate for the effects of this particular channel. Equalizers such as maximum likelihood, MS stands for maximum likelihood, MMSC is maximum mean square error criterion, DFE stands for decision feedback equalizers, and active equalizers that employ LMS, RLS, recursive least square algorithms. LMS stands for least mean square algorithm. They must be considered. Equalizers also must be carefully designed to compensate for this particular channel estimation technique. Okay, always you remember that equalizers must be designed as a receiver. And there are one more equalization techniques are also in 5G, such as blind equalization and semi-blind equalization techniques are also there. Research scopes are going on in particular this one also. Okay. Coming to this green communication in 5G. What is this green communication in 5G? Green communication is the practice of selecting energy efficient communications and networking technologies and products and minimizing resource use whenever possible in all branches of communication. So green communication is the practice of selecting energy efficient. So it should be efficient in energy. Whenever it is there, it should be efficient in energy and networking technologies and products and minimizing resource use. So user resource must be minimized whenever possible in all the branches of communication. So green communications will be another major attribute of 5G systems. As power consumption from the information and communication technology sector is forecast to increase significantly in the coming years. So green communication will be another major attribute for message system. Power consumption from information and communication technology is forecast to increase significantly in the coming years. It aims in designing energy efficient spectrum utilization in 5G systems that improve the overall performance and quality of service. Ultimately, this one is we are going to have the overall performance and high quality of service is designed to the customers. At the same time, high bit rate is also desired. Designing efficient systems that minimize electromagnetic radiation in environment has also a good scope for it. Designing efficient systems that minimize nowadays electromagnetic radiation, I have to know that everybody is using the mobile cellular phone. So the research on this particular electromagnetic radiation, what are the effects of this on the human body, all these things must be carefully considered. That also has become the research scope. That also is one of the category of green communication. We are using the green communication which is favorable to the customers. So it has also been service. Coming to the applications of 5G communications at a glance. So enhancing mobile broadband, okay, having a gigabit speed, and so before going to the applications, so what they do is those who are doing the MTech or PG communication, this MTech communications or whatever. When you are doing some project, so choose some upcoming 5G technology, and you can work on that. Now advanced versions of MATLAB has also come, and you can take the system and you can write your program and you can simulate this one, because MATLAB newer versions have come also. So whatever is there, you have to show that. So see, whenever you write any algorithm or in the research, so what is the main concept of research? So that I am telling you. So whenever you write an algorithm or develop an algorithm, so that algorithm must be superior to the existing algorithm. Always